Now in this video, we will be solving a two variable problem as well as a three variable problem. The main idea for solving or for making this video is so that we can solve a one type of three variable problem. This could be done with the help of a two variable problem, as we will convert a three variable problem into two variable problem and then continue solving it. For example, if I am taking a very simple equation of very simple linear equation of two variable, let's say ax plus by plus c is equal to 0, then it is very obvious that it is having two variables, and if it is having two variables then it requires at least at least two equations so that we can find the value of x as well as of y. Now let's there are many methods for solving such type of equations, like elimination method, substitution method, but the most underrated method is the cross multiplication method. Let's say we are having two equations, a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Here A1, A2, B1, B2 and C1, C2 all are the constants. If I'll say that these two equations are there and these two variables are there, then it is not wrong to say that it is very easy or very feasible for us to find the values of x as well as of y. So we could be doing with the help of cross multiplication method. Now in the case of cross multiplication method, the general form of cross multiplication method to solve such type of equations comes in the form, as we can say, x upon b1 b2 c1 c2 is equal to y upon c1 c2 a1 a2 is equal to 1 upon a1 a2 b1 b2. This is a general form of representing the two equations. This is a general form of representing the two equations or the solution of these solution of these two equations. Now, how could we solve it? As the name suggests, cross multiplication. So we will be cross multiplying these values which are constants and then get the value of the variable x as well as of y. So what can I write as? I can write as x upon b1 c2 minus b2 c1 is equal to y upon c1 a2 minus c2 a1 is equal to 1 upon a1 b2 minus b1 a2. This minus sign which I have put in between, this minus sign which has been implemented or which is put in between, is basically done to subtract these two values, and when these two values are multiplied they are subtracted, right? So or we will just the difference of these two values, to be more precise, the difference of these two values gets us the values of x, y as well as of z. So I can write as x is equal to, we will equate x b1 c2 minus b2 c1 equal to 1 upon a1 b2 minus b1 a2 to get the value of x, which will be x is equal to b1 c2 minus b2 c1 upon a1 b2 minus b1 a2. Now this is a direct formula, but instead of rectifying the direct formula, we can easily start with the expression as stated here. We can simply start with the expression as stated here. Then we will multiply the values or cross multiply the values, take their difference, and can get the values of x as well as of y. Similarly, for y, we can calculate the value as y upon c1 a2 minus c2 a1 is equal to 1 upon a1 b2 minus b1 a2. Most of you must be familiar with this problem. So it is very common way of solving the linear equation of two variables, and this is one of the most underrated method that I believe, because this method is generally is out of the syllabus and from many books, as well as this method is generally not used. Elimination and substitution methods are something which are used very commonly now these days. So this method is very efficient as well as useful for solving the higher variable problems, or to take the ratio of variables when the number of variables are more than 2. Continuing with this, we can say that C1A2 minus C2A1 upon A1B2 minus B1A2. This will be the values of x as well as the values of y. Now, we will not learn these values. We will simply start with putting the values like this. We'll start putting the values like this, and then continuing by cross multiplying, taking the difference, and then solving the equation. For example, I'm taking a general equation like, for example, I'm taking, let's say, 3x minus 4y is equal to 12, and 6x minus 9y is equal to 18. So firstly, we will convert them into general form. The general form of this will be 3x minus 4y minus 12 is equal to 0. We have to make the left hand side with all the variable as well as the constants, and the right hand side as 0. The general form of this will be 6x minus 9y minus 18 is equal to 0. From this, we can get the values of x. From we can get the values of a1, a2, b1, b2, c1, and c2. So what can I say for a1 is it is equal to 3. For a2, it is equal to 6. b1, it is equal to minus 4. b2, it is equal to minus 9. c1, it is equal to minus 12, and c2, it is equal to minus 18. Now, after doing this, we can easily solve the equation 3x minus 4y equal to 12 and 6x minus 9y equal to 18 with the help of cross multiplication method. Yes, you can definitely solve these equations with the help of another methods also, but I'm just elaborating the method so that we can use it for the three variable problem, as this method, the cross multiplication method, has its own use in the three variable problem. So just an common or normal example that we're going to use it. For x, we can write as x upon a b1 minus 4 and b2 minus 9, then c1 minus 12 and c2 minus 18. For y, we can write minus 12 minus 18 and 3 6, for and it is 1 upon 3 6 minus 4 minus 9. I have written this as of the form represented here, right? As of the form represented here. Now we can solve this. So for solving it, how could we solve this? It could be solved as x upon minus 4. Minus 4 into minus 18, it is 72. 72 or minus 108. 72 minus 108 pi upon minus 72 plus 54 is equal to 1 upon minus 27 plus 24. So we will get the values x upon 36 of minus y upon will get 1218 of minus and 1 upon it will be minus 3. As we can see that minus 3 is common in all the three ratios. So we can cancel out by minus 3, which is 1 time, which is it will be 12 times, it will be 6 times, and it will be 1 times. So x will be 12, y will be 6, and hence we have solved the equation with the help of cross multiplication method. Now, after solving this with the help of cross multiplication method, this is something which is of most importance. The example was just a simple reference. How could we use this method, right? We are having two variables, so two variables requiring two equations, and then we have solved it. Now for the three variable problem. In the three variable problem, let's say we are having the equation a1x plus b1y plus c1z is equal to 0, and a2x plus b2y plus c2z is equal to 0. It is very obvious that there are two equations. Now, if there are two equations, if there are two equations, then there must be two variables so that we can solve the value of each variable. But the number of variables, but the number of variables are three. Number of variables are three, which are x, y, and z. So, will it be feasible for us to solve the values of x and y or to calculate the values of x, y, and z? The answer is no. We cannot calculate the values of x, y, and z easily. Or I can say that we cannot calculate the values of x, y, and z, but we can calculate the ratio between x, y, and z. If the ratio of x is to y is to z can be calculated with these two equations. Consider this important point that I am only discussing the case where there is no constant on the left hand side, right? Right hand side is obviously 0 and there is no constant value on the left hand side. So when there is no constant value on the left hand side, I am discussing that case. It is not a general case for all the equations involving three variables. It is some particular case of three variable problem. So what our work will be do what our work will be to calculate the ratio between x, y, and z. Now if I'm having the equations a1x plus b1y plus c1z is equal to 0, and a2x plus b2y plus c2z is equal to 0. I can say if I divide if I divide both equations by the variable z, then what will I get is a1x b1y plus c1z whole divided by z is equal to 0, and a2x plus b2y plus c2z whole divided by z is equal to 0. So it could be said easily that A1 can be written as, A1 the coefficient can be written with the variable x upon z, plus B1 as coefficient can be written with variable y upon z, plus C1 is equal to 0, as the z and z gets cancelled. Similarly, for the second equation, A2 x upon z plus B2 y upon z plus C2 is equal to 0. Now, what is the use of dividing? What is the use of dividing the whole equation with the variable z? The idea is very simple, as we have converted this into two variable form. If you clearly observe, this is a two variable form of equation or two variable problem that has been converted to. And if it is a two variable problem, then we know very well that we can write the solution of two variable as x upon z upon b1 b2 c1 c2 as y upon z upon c1 c2 a1 a2 equal to 1 upon a1 a2 b1 b2. Now we are using which type of method here? The cross multiplication type of method. X upon Z B1 B2 C1 C2 is equal to Y upon Z C1 C2 A1 A2 is equal to 1 upon A1 A2 B1 B2. This is the method that we have used here, right? How to remember that which variable or which constant has to be taken at first? Just consider this A, B, and C and move it in the anti-clockwise direction. Firstly, we will taking all the values of B, then we will take all the values of C, then we will take all the values of A, and at last A and B. So by that we can arrange the denominator in that form. B1, B2 taking the first values, then C1, C2 taking the second values, then C1, C2 continuing with the second value, C1, C2, A1, A2, A1, A2, B1, B2, right? In that manner. Now the thing is, we are having x by z and y by z. Although we need the ratio between the three variables x, y, and z. So what can I do? I can multiply the whole equation, the whole set of equations. I can multiply by z. After multiplying by z, what I will get is x upon z into z upon denominator remains the same, b1 b2 c1 c2 equals to y upon z into z. In the denominator I will get c1 c2 a1 a2 and multiply by z a1 a2 b1 b2. Now here the z gets cancelled out, and what we are left with? We are left with x upon b1 b2 c1 c2 equals to y upon c1 c2 a1 a2 is equal to 1, sorry, z upon a1 a2 b1 b2, right? Now denominators involving a1 b1 c1 and a2 b2 c2 are basically the constant values, and these constant values could be solved using which method? Cross multiplication method. And after solving with the help of cross multiplication method, we can easily get the ratio between x, y, as well as z. right? So our purpose will get fulfilled by this equation. Now we will be doing cross multiplication. So for cross multiplication, as the name suggests, let's cross multiply the values. So we will multiply these values with each other diagonally, right? Or we can say cross multiply. So what you will get, x upon b1 c2 minus b2 c1, the similar way as we have done in the two variable problem. C1 a2 minus c2 a1 is equal to z upon a1 b2 minus a2 b1. This is the most important form that we will going to discuss. This is the most important form that we will going to discuss, right? This is the only form which is considering. This is the only form which is we will or which will be we will be considering to solve the problems involving of three variable problem of the type a1x plus b1y plus c1z or a2x plus b2y plus c2z. I've taken one example. If you want to try, you can give it a shot. Now, in this, let me zoom a little bit. Yeah. So, if you want to try, you can pause and take a shot at this example. Those who want to get entertained with the show can continue. Now, in this, we know that there are three variables, right? There are three variables and three equations: x, y, and z. Three variables and three equations. If there are three variables and three equations, then it is very easy for us to get the values of x, y, and z. But there is a one little problem. The problem is that in the third equation, we are having a higher degree, not the normal degree of 1. As in the above two equations, in these two equations, we are having a highest degree of 1, but in the third equation, we are having the highest degree of 3. So it will be not much easier for us to calculate the values of x, y, and z. But if if we use if we use a three variable problem solution using ratio between x, y, and z, then if we get the ratio between x, y, and z, we will substitute we will substitute those values substitute those values in third equation and can get the value of x, y, and z. When I'm referring to substituting those values, I'm talking about the ratio ratio between x, y, and z, right? So it might not get confused with it. Let's start with the problem. Now, as the problem states, 3x minus 4y, 3x minus 4y plus 7z plus 7z is equal to 0, and 2x minus y minus 2z is equal to 0. So let's calculate firstly all the constants, coefficients to be more precise, of x, y, and z. So a1 is equal to 3, a2 is equal to 2, b1 is minus 4, and b2 is minus 1, C1 is 7, C2 is minus 2. Now, we know that using cross multiplication method, we can easily calculate the values of we can easily calculate the values of x, y, and z. No, we can easily calculate the ratio between x, y, and z. So x upon b1, b2, c1, c2 is equal to y upon c1, c2, a1, a2 is equal to z upon a1, a2, b1, b2. I'm using that same formula that we have achieved in the three variable three variable while discussing the three variable problem, right? Here, this I'm only using this formula, or we can say this formula to get started, right? Now we will cross multiply and let's substitute the values. So the values are x upon a1, x upon b1, which is minus 4, minus 1, 7, and minus 2 is equal to y upon 7 minus 2 and 3, 2 is equal to z upon 3, 2 and minus 4 minus 1. Now cross multiplying these, so what we will get, minus 4 will get cross multiplied by minus 2, so it's minus 8 and minus of minus 7, which will be plus 7, is equal to my 8, sorry, it will be 8 and 8 minus of minus 7, which will be 7. Y, it will be equal to 14 minus 14 minus of minus 6, which will be 20. And Z, it will be equal to minus 3 of minus 3 minus of minus 8, that will be 5, right? So after solving this, we can write this as 15 directly, right? You can cross multiply these values and get the required set of equations. Okay, so this further can get cancelled by 5. So further simplifying it, we can get x upon 3 is equal to y upon 4 is equal to z upon 1. So what can I say from this is that the ratio x is to y is to z is nothing but 3 is to 4 is to 1, right? Now if I assume all x upon 3, the x upon 3, y upon 4 and z upon 1 equal to some constant k, sorry, if I assume the value x upon 3, y upon 4 and z upon 1 to some constant k, then I can say x upon 3 is equal to k, like for example, like k, y upon 4 is equal to k, and z upon 1 is equal to k. So x will be 3k, y will be 4k, and z will be k. Now this we have got the values, and as we have got these values, we can easily say that now We have got these values x equal to 3k, y equal to 4k, and z equal to k. We can substitute these values in the third equation so that we can get the answer. So what is the third equation? 3x cube minus y cube plus z cube is equal to 18. This is the third equation. So what we can say is 3x cube minus y cube plus z cube equals to 18. Substituting the values, x is equal to 3k, so 3 into 27 k cube minus y cube, which is 64 k cube, plus z cube, which is k cube, is equal to 18. It will become 81 k cube minus 64 k cube plus k cube is equal to 18. So it will be k cube is equal to 18, k cube will be equal to 18, or k cube is equal to 1, or k is equal to 1. So the value of k will be 1. As the value of k is 1, so we will substitute these values in the we will substitute these values in this equation, and to get the values of x is equal to 3, y equals to 4, and z equals to 1. That will be our answer. Now, how easy it has become. As if earlier we have used if in this case, if in this case we have taken or solve the equations with the help of x, y, and z individually, like by substitution or by elimination, then it would have been become a such a complicated task to solve the equations and to get the values of x, y, and z. But with the help of this cross multiplication method, or using or converting a three variable problem to a two variable problem and then solving with cross multiplication, it has become such an easy task for us to get the values of x, y, and z. There is one more example if you want to try. This is one of the more example that we can try. So you can try and comment your answer in the comment box. My name is Prakhar Jain. If you enjoyed it, give a thumbs up. Thank you.